There we go. Hi, everybody. Hey, thanks for coming out. I'm William with WMD. Been making modular synthesizers since 2010, and I'm here to talk about Skorpion, a piece of gear that I have been working on since 2020. So, long time coming, idea in the shower, and like, how can I make this thing? There's an interesting electronics idea that I wanted to explore. So, to give you a little bit of history, I have a few different kind of old school designs, one of them being Synchrodyne, which is this exploration thing that I just messed around with on a breadboard for years. And I wanted to explore what this circuit does. This is the same kind of product. This is not something that is solving any sort of issue or problem or hole in your rack. This is purely an exploration from my mind and my heart, trying to come up with something cool that is fascinating and interesting to me. So that is Skorpion. So that's the piece. Let me switch the screen. No, you're good. So that's the render of what it looks like. So you can kind of see your mind around it a little bit. I'll show you some of the older versions as we go through here. I'm going to talk a little bit about what wavefolding is, why it's cool, and then go through some like demo and audio examples as we go here. All right, so wavefolding, what is it? It started off in, actually Simon told me this, some radio wave stuff to stop radio stations from being too powerful. Instead of clipping, they would basically reverse the signal and like not clip but rectify and reverse going down. So Don Buchla took this idea, figured out how to do it with op amps, and made the Buchla style wavefolder, which is wonderful sounding. It is very nonlinear and kind of lacks really high harmonics, but it's a beautiful sound. We've all heard it. It's lovely. And then Surge, and this is a crappy video from my Synchrodyne. I couldn't find a good wavefolding image of the Surge wavefolder as I was preparing this. But the Surge takes, instead of just op amps, adds diodes. And the diodes, every time you run through them, inverts the signal, lose a little bit of level. You run through another one, you lose a little bit of level, run through another one, lose more level, and you keep going like that. And you end up having to have a lot of gain in order to get your signal up to the right level. Sounds good, but has harmonic limitations. You lose a lot of high frequencies. Even though you're adding harmonic content, you don't retain like the crispiness of the signal. So what I had the idea for in the shower is called vector core wavefolding, which is really a slew circuit at its core. So the Surge DOSG, we've all used it. It's in maths. It's in the mini slew that we put out a few years ago. And it's a very powerful core, but the original version is pretty crappy. It doesn't track volt per octave. It's not temperature stable. It's fast, and it does get to voltages accurately. So it works as like a portamento. You can run volt per octave through it. It's great. But it needed to be improved. So over the last few years before starting on this, we put out our time warp module, which uses a VCA core instead of the dual transistor thing in the slew circuit, and made a bunch of modifications to make it temperature stable and track volt per octave. So what the vector core can do, it goes up, it goes down, it can stop, it can go to 0, and you have control over how fast it does that and where it's going to go to. So that's all that you have control over, but that's a lot of stuff. That's like most voltage controlled in synthesis. So to make this cool little slew core into a wavefolder, most of what Skorpion is me tinkering with logic and trying to make it go up and down a bunch of times as a triangle wave goes by. So I added a stack of comparators. They sit there and flicker and toggle and make all kinds of digital noise, but all of this stuff makes the core go up and down much faster than the incoming waveform. So, and it can go to different places. It can go up to 5 volts, down to negative 5 volts. It can go to the input voltage. It can go to some other waveform. So you can override the output with a new input. So here's a picture of how this works. So if the slope is 1 and you have all these thresholds, which are set by the sliders on the Skorpion, then it reverses direction. That's the gist of it. So every time you reverse direction, you get less amplitude, more harmonics, and yeah, higher harmonic content. So as you increase the slope, which you can do in the slew circuit, you end up with even more harmonics, more gain, and then the yellow line here is, well, the red line is unlimited, and the yellow line now is limited to the input waveform, which gives you this really interesting, like, overleaved of your input to this wavefolded signal. So you retain some of the harmonic character of that triangle wave in this case. So next is 4 times slope, and just an example of unlimited goes up to 5 volts and it clips, and then you can see the yellow is like bound and kind of stays more in the center. So I enjoyed drawing these pictures, so I wanted to share them with you. This was like me theorizing, is this thing going to work? How is this thing going to work? And so this is that, and I get to share it finally. So this is the first revision through the 4th revision, and all of that time was spent messing with the circuit and trying to get it to actually work. So the first prototype didn't work. There's a whole bunch of crappy wires on the back, like upside down parts that I'm soldering to, trying to fix stuff and make it actually do the thing that I thought it would do. With this version, I played with this for a few years, really, once I got it working. I stopped working on it in 22 because of pandemic stuff, and like WMD had some issues, and we went through some major changes and closed for a while. And so I thought this was never going to come out. But in 22, I got it to this stage. This is the 1.04 panel version. And the design was okay. The sound was good, but it didn't have internal modulation. It didn't have like the magic that I was hoping to find, so I had to keep going and figure out what else to do with it. I also had this button interface up top, the green circles, and these LEDs, and the way we had updated our manufacturing, the buttons were easy to install, but the LEDs were all light pipes. You had to get in there around these sliders with tweezers, and this was like the worst thing to build, so this had to change. So to make it better, this was version 1.06, which I kind of designed in the background. I never built one of these, but what I thought about was, so we have the thresholds on their sliders, and in 1.04 they were real time, so they're just direct to analog. And what I wanted to do was make a digital overlay that would allow me to snapshot the thresholds and then also drive the voltage to a specific place, so have basically a sequencer inside So this prototype was going to be 6 different comparator lanes with DACs and voltages and everything. And I started working on it, started doing the board layout, and there's so many parts I couldn't physically fit them on the board the way I wanted to. So I gave up on this, and I thought I was going to be done and quit on this project. But I kept playing with the 104 version. I had it in my case, performing with it. It's very fun. And finally, I think I brought it to Superbooth 24, and it got a really good reaction. So I decided to continue to work on it, and this is what I came up with. It's a little bit wider. This is a 20 HP module. The original was 16. Added 2 more comparators, so you get more harmonics. It also made the interface simpler, and it gave me the important room to actually do the circuitry and fit it all in there. So this is the 1.07 version I worked on for a while. And let's see, did I miss something? Oh, I was going to do a demo in between this, and I'm just up here talking. Let's see. Yeah, I missed several demo notes. Cool. All right, I'm on it. Great. So let me show you first the triangle wave going into the Skorpion, which we've heard a bit. Let's do just a little bit of reverb. And okay. All right, so all the sliders. Could I get the down camera?
Yeah.
Cool.
Sorry.
No, you're good, Tom. No worries.
More focused on the video.
Yeah. Great. All right, so that is a triangle wave. Hooray. Let's see, we'll go up an octave. And so basically, no slope, reduce that. All right, so this, I'm gonna bring a threshold in, maybe. No, fold, there. So this is those horizontal lines. As you cross each threshold, across the input waveform, it'll reverse direction. So you can bring multiples of those in. And it changes the sound quite a bit. And then this is the slope increasing. And let's see, this is going to 5 volts. Change this to look at the input waveform. So now it's going to either, well, imagine the input waveform makes like a triangle, like where the voltages can exist within the top and bottom. It's full wave rectified and then inverted also. And then, so let's imagine we want a more normal, classic wavefolder sound, because these are pretty hard to get all to be even. It'd take a long time to actually sit there and do that. So I have an equalize switch, which makes it harmonically, like, perfect. Right? You can tame it a little bit. Back to 5 volts. Then you have shift, which just moves that incoming triangle wave vertically up and down, but it blasts it equally against all the comparators, so you get this nice warble effect. You can, of course, CV this. And then we also have shape controls. So this is taking the input voltage and routing it as feedback to the slope knob. So as I turn up or turn down shape, it's inverting. You get less harmonics as the wave gets higher. You can do the other way. And then you have your wavefold control, which is the input VCA for the incoming signal against the comparators. So yeah, that's what it sounds like. Yeah, great. All right, next. So the original concept did that, and it sounded great. It was lots of fun. And then we got to this one. Oh, he doesn't. Hey, Tom, can I get the... So this one, which I never made, but I conceptualized the targets. So let me show you how that works. So go back to this, turn these down. So turning this knob, sorry, it was brief. Go back to this. So to access the thresholds, that's a default setting. To access the targets, there's a spring-loaded toggle switch, and the LEDs pop to what the current targets are, and the faders just, when you touch them, they have action. So we'll do just this first target, and fold once. So you can see this is now driving the voltage to that voltage, or to where it, from 0 or higher. Do the second one, bring that in. So now you can kind of draw your own waveform, which is interesting, honestly not amazing, but the targets can be used as feedback, which is a lot more interesting. So if we ignore that and just go to 5 volts, use target, now you can control the slope of any specific threshold. So you can get just some sharpness instead of every wave or every bit of the wave being sharp. You can get just little specific bits. That's controlled with this one. So you can see the wave changing shape there. Yeah, so that's fun. The target stuff is really great for feedback, and that was not part of the original design spec. That was like something I discovered later on that I really enjoy. All right, so showed this one at Super Booth. Finally started to work on it again in late 2024 and had prototypes delivered like late summer. And then we're working on the Performance Mixer Mark II suite, coding, testing, working really hard on getting that done. So this sat on the shelf yet again for another like 6 months until right before Super Booth 25 when I got to actually work on it. Got it working and showed this earlier this year. Which went very well. Same good response. When the fuck's it going to be done? I don't know, but we're finally actually getting close to that. So, all right. So from here, what I added on this version, let's see, was this target halt mode where instead of the waveform always running, if these targets are 0, so all the way down, you get this, let's see, let me turn that up. you get stair stepping where it stops the waveform. So this is normal mode. And this, you can kill the waveform instead of having it jump to the next one. So more options for drawing things. So you can turn off sections. So great for tone shaping, for experimentation. Like, you're not gonna sit here and have this sound in your mind and like try and make it. That's not what this is for. This is for like playing in the moment and coming up with something really cool. All right. So next, there we go. This is almost the final version. And this has everything incorporated that I thought it needed. I moved because I had the DAX, I'm trying to reorganize myself here. Because I had the DAX, I had the second page, I started to play with the thing. I was like, you know what this needs is modulation. We have all these jacks, but like my test bench has one LFO in it. Okay, fine. I have DAX. I might as well just sit here and write code and see what I can come up with. So we added on every slider, a third mode called animate or macro envelope, where in the microcontroller, there are 8 LFOs that are desynchronized, so they're never non-repeating, non-overlapping, and those can control the thresholds. So to access this mode, you push and hold this macro setup switch, the spring-loaded switch to the right, and you have the main envelope, which goes from like 50 milliseconds to 12-ish minutes. So kind of long, but it's not intended to be precise. It's intended to be like fun to play. So we'll leave it medium, not too long. And then threshold LFO amount here, and then the rate. And it has to be on to see it. So run audio. Put this back to normal. Make sure these are all off. So this is doing this, pushing all the LFOs around. Let me turn the rate down. So that's off. That's a static waveform. You get this nice bit of animation. And this can be gated if you'd like it to. It can be really heavy if you turn the rate way up. And you can stop it at any time by clicking on the equalize switch, because to have the targets exactly, or have the thresholds exactly spaced out, they can't have any modulation. And then you can turn it back off and go back to whatever your steady state is. So that's part of the macro animation. The other part is, turn those off, is there are 4 hardware DACs that route to fold, slope, shift, and shape. And those can be set up in the same fashion, moving these around. I think the fastest time is like 3 hertz, 4 hertz. It's not intended to be very fast. And then these can be either envelopes by doing a gesture move or LFOs. What I did there is up, down, or down, up to switch modes. And then, let's see, turn those on. So we have LFOs here. threshold. Nope. There we go, LFO. So you get 4 built-in LFOs, or envelopes, basically. And those go through the attenuverters, and then everything turns off with the macro envelope. So if you turn everything on, it can go nice and crazy, should you want it to. I like this a lot better when it's like pretty slow and tame for nice textural, slow developing, subtle changes. So yeah, so that's the macro envelope and animation, and where it gets its name, Skorpion Waveform Reanimator, is that it's like right now, I'm basically sending in an input, a volt per octave, and the outputs. That's it. This macro envelope thing is not actually connected. So, or it's not on, it's not sending a gate. So, the reason we need volt per octave is because it will be exactly perfect, timbrally accurate, like a low-pass filter. You just have to tell it what pitch you're on, and it'll make sure to track with. But without that, it'll sound more like a normal wavefolder, which doesn't really track. Like, you start to lose harmonics. But yeah, this one won't. It'll spit out well above 20 kilohertz of awfulness, if you would like. Yeah. All right. So that's macro animation. Great. So here's on the screen, the slides. So here's a few photos of like various prototypes of hacking stuff together. I made lots of mistakes along the way of this, as I do with most products. Like, design is well-intentioned and many mistakes are made along the way. So this is hacking in, like, reversing the polarity of op amps so that they're inverting instead of non-inverting, or vice versa. I got a header backwards, so I had to like cut all 16 traces, not quite 16, 12 traces, and like reroute them through the mess. And then this last one, the red one, is the next thing I'm going to talk about, which is adding the last bit of making it stereo. So everything we've heard up to this point has been mono, and it sounds great mono. It's big, it's nasty, but I had an idea for, well, why not stereo? We had a few other modules that are stereo. Our mixer is stereo. Might as well see what we can come up with. So I had an idea for how to make a stereoizer, and it's basically a small delay from 0, as close to 0 as possible, milliseconds, to about 15 milliseconds. So you're in like the Haas effect, kind of binaural, your ears can tell apart, but like you can't really hear that there's a delay. There's no slap. So I wanted to incorporate that, but I wanted to keep the low end intact. So there's a mid-side matrix that the the wet signal goes to the low-pass filter and to the mid. And then the highs get filtered through high-pass filters. There's a delay and the dry, or the wet, delay and the wet, those go through high-pass filters. And that the sum goes to the mid and the difference goes to the side. So it's this whole mess of op amps, and trying to fit that control onto a knob it's analog and it's ugly. Like, the schematic is ridiculous, but after a few revisions, it fucking works and it sounds great. So I was going to do this like slew core thing and have a second copy, but it's digital, and delaying digital signals surprisingly difficult when they're like 200 or 300 kilohertz. So that's like FPGA land. I didn't have the chops for doing that for this project. That's way beyond the scope. So I built a small delay on a microcontroller that runs at 133 kilohertz. And that's more than enough for getting all of the information and having that like ultra low delay time. so that it's actually transparent when it's off. So I think we're running in stereo in here. From where I'm at, it doesn't sound very stereo, but that is okay. So this is mono. Let me turn it up a little bit. Does that sound stereo? Okay. You can hear the separation. Back to mono. So that's the DC, which there's a switch for. DC looks better on the scope, so I use that mostly for demos. And then the filters mode. So this is where the low is actually in the middle and the high pass is to the sides. And so how this works, from wet to about 3 o'clock is just adding delay. And then beyond 3 o'clock, it adds a slow LFO that speeds up and increases in amplitude. So I think that sounds nice. So there's back to DC, which is better on the scope. But so with that, I think I'm done with this thing, at least design-wise. And then there's always little things to fix and to tinker with and to play with. And so that's like the difference between 1.10 and 1.11, which is the final actually done version. And this is that. There's just wires on this one and it's covered in epoxy so that I can fly with it. So, but yeah, we're effectively done. So this is like I kind of said earlier, this is my, WMD is a company, we make things. Most of the things we will make for a long period of time because they are tools for people. This is not a tool. This is art. This is like my soulness, weirdness to make this happen. So I'm only doing like one run so that I can let it go and not try and fix shit in a second run because I know that something will come up because it's not perfect, but that's okay. And because it's really, I like it a lot as it is. But I mean, we all put out music. I think you often go back and you're like, oh, I could have fixed this or I could have changed this. I don't want to do that with this. I've done that with most of the other products because improving them is necessary little by little, manufacturing-wise or just sound-wise or whatever. There's a technical imperfection. I'm not going to do that with this. I'm going to let this go and be done with it. So I'm doing one run and calling it so I can focus on something else. So that's the main reason we're doing one run of it. Yeah. So let's see.
Will it be pre-orders or something like that? Or?
Yeah, it's pre-order only. So I'm going to make as many as I sell, and then that's it. We're closing pre-orders on October 8th. So like 2 weeks from now. I'm going to Machina Bristronica after this. And then, yeah, now that it's done, I can finally close the pre-orders and move on. Yeah. Yep. So I think that's basically it for Skorpion. Yeah. Right.